Hey guys, today we're looking at 3.3, day 1, which is adding, subtracting, and multiplying radicals. So to add or subtract radicals, you must have like radicals. Like radicals are radicals that contain an identical radicand and identical index. Okay, so that means that we have square roots added together, cube roots added together, and then we have the same number or radicand underneath the root. So here we want to tell whether the following radicals are like. So 5 root 3 plus 11 root 3, both are square roots, so they're good. Both have a 3 underneath, so these are like. Now in this next example, we have 5 square root 3 plus 11 cube root 3. Now even though they both have a 3 underneath, one's a square root, one's a cube root, so this would be a no. And then finally, in our last example, we have 5 root 3 plus 11 root 2. While they're both square roots, we have a 3 and a 2, different radicands, so this would also be a no. All right. Now, if you have like terms to add or subtract, you just add or subtract the coefficients and keep the same radical expression. So it's very similar. We want to treat the radicals like variables. Okay, so we'll see how that works here in example A. It says to simplify. So number 1, I have 5 root 11 plus 6 root 3 minus 8 root 11 minus 19 root 3. So if you think of it like this, 5x plus 6y minus 8x minus 19y. Treat the radicals like variables. So what I could do is rearrange everything. Okay, now I'm just adding or subtracting my coefficients. I leave the radicals alone. So 5 minus 8, I get negative 3 root 11. 6 minus 19, I get negative 13 root 3. There we go. Number 2, 8 root 2 plus root 2. Okay, so those are both the same. Square root 2, square root 2. I have a 1 in front, so this would be 9 square root of 2. All right, in number 3 and 4, we are subtracting. So root 5 minus 10 root 5. Remember, there's a 1 in front here, even though we don't write it. So this is like saying 1x minus 10x. We would get negative 9. In this case, root 5. And now I have the square root of 6 minus the square root of 6. Well, whenever you subtract something from itself, we just get 0. All right. In example B, we're adding a little bit more to it. Not only are we adding or subtracting, but we also have to simplify. So in number 1, I have 5 root 8 plus the square root of 18. So I know that the square root of 8 simplifies. Okay, 8 is 4 times 2. So 5 times the square root of 4 times the square root of 2. Square root of 4 is 2. 5 times 2 is 10. Okay, so now this becomes 10 root 2 plus, let's simplify the square root of 18. Okay, 18 is 9 times 2. Square root of 9, square root of 2, I get 3 root 2. So I took this mess of unsimplified radicals, made them simplified. Now they both have the same root in radicand. So I'm taking 10 root 2 plus 3 root 2, and I get 13 root 2. Okay, number 2. I have 8 root 12 minus 5 root 48. Okay, so we're going to try and rewrite this. 8 root 12. Got the square root of 4 times 3. 8 times the square root of 4, square root of 3. 8 times 2, square root of 3. I get 16 square root of 3. All right, now we have 5 root 48. 48 is 16 times 3. Square root of 16 is 4. So I get 20 root 3. Okay, this becomes my new problem. 16 root 3 minus 20 root 3. I get, negative 4 root 3. All right, so go ahead and pause, try 3, 4, and 5 really quick. For number 3, I need to simplify that square root of 24 and then the square root of 54. So 24 is 4 times 6. 3 root 4 times root 6. I get 3 times 2 times the square root of 6 equals 6 square root of 6. Square root of 54 is 9 times 6. Square root of 9, square root of 6, 3 root 6. So now I'm working with 6 root 6 minus 3 root 6, and I get 3 square root of 6. Okay, number 4. Square root of 125 is 25 times 5. So I have 4 times 5 times square root of 5, and I get 20 square root of 5. Okay, now for the next one, 9 square root of 80. 80 is 16 times 5. So 9 times 4 root 5. We get 36 square root of 5. Okay, so now my new problem, 20 root 5 minus 36 root 5. I end up with negative 16 square root of 5. All right, and last but not least, for question number 5. 7 square root of 12 is 4 times 3. 7 times 2 times the square root of 3. 14 square root of 3. 8 square root of 8 is 4 square root of 2. 8 times 2 times the square root of 2. So now this becomes 14 square root of 3 minus 16 square root of 2. So what ends up happening, that's our final answer. We can't simplify any further. It's like saying 14x minus 16y. You can't combine any like terms. So that would be it. All right, good. Example C, we want to decide whether it is true or false that the expression is fully simplified. If it's false, correct the error. So here in this problem, I have 5 cube root of 8 minus 4 cube root of 8 equals the cube root of 8. So if I check it out, same root, cube root, same radicand. 5 minus 4 is 1. So yes, this is fully simplified. Okay, number 2 in this example, 3 root 2 plus 4 root 5. Well, those are unlike terms, okay? Again, it's like saying I have 3x plus 4y. There's nothing I can do with this, so yes, this is fully simplified. Nothing more we can do with it. Number 3, 7 root 18 plus 2 root 50. That is not fully simplified. I know it's not because I know that I can simplify 18 and 50. So what I'm going to do here is simplify both. No root. Okay, so now my new problem becomes 21 square root of 2 plus 10 square root of 2, and I get 31 square root of 2. That is my fully simplified answer. All right, and finally, 3 root 10 minus the square root of 90 equals the square root of 10. Well, 10 I know doesn't simplify any further, but this 90 does. Okay, we have the square root of 9 times the square root of 10, and that becomes 3 root 10. So my problem, 3 root 10 minus 3 root 10 should equal 0, not the square root of 10. All right, good. All right, and finally, multiplication is a lot easier because there's not as much you have to worry about. You don't have to worry about the like terms. You just have to worry about simplifying completely. So in number 1, what we do is we're going to multiply the coefficients, multiply the radicands, and simplify. So you can rewrite this if you want. I have 5 root 3 times 2 root 7. We can think of this as 5 times 2 times the square root of 3 times the square root of 7. Multiply my coefficients, I get 10. Multiply my radicands, I get the square root of 21. 21 does not simplify any further. There's our answer. In number 2, 4 root 6 times 5 root 2. So 4 times 5, square root of 6, square root of 2. I get 20 square root of 12. But I know that that square root of 12 is going to simplify. Square root of 4, square root of 3. 20 times 2 to the square root of 3, I get 40 square root of 3. So that's what happens when I multiply. All right, and last but not least, in question number 3, 2 root 8 times 3 root 5. So we rewrite it, 2 times 3 times the square root of 8 times the square root of 5. I get 6 times the square root of 40. Well, I know 40 simplifies because it's got 4 times 10. Square root of 4 is 2. I get 12 square root of 10. All right, so that's adding, subtracting, and multiplying. Let me know if you have any questions.